Hey everyone, welcome back to this channel. In today's video, we are going to solve a very interesting and easy Leetcode problem, count symmetric integers. That is problem number 2843. We will look at two different approaches. First, a brute force method that works for all cases, and second, an optimized method that improves efficiency by using observations. So let's get started. You are given two positive integers, low and high. An integer x consisting of 2 into n digits is symmetric if the sum of the first n digits of x is equals to the sum of last n digits of x. Number with an odd number of digits are never symmetric. Return the number of symmetric integers in the range low and high. So let me explain this question to you. In this, you are given two numbers, low and high, and you need to count how many numbers in that range are symmetric integers. But what is a symmetric integer? So first we understand what is symmetric integer. Let me explain. A number is symmetric only if it has even number of digits. For example, we take 2, 3, 5, 11, 16, 2, 2, 3, 2, 300. We will understand this by taking these kind of example. This number of digit is 1. Number of digits 1. Number of digits 1. Number of digits 2. Number of digits 2. Number of digits 3. Number of digits 3. So we will check only the number which has even number of digits. 16 has even number of digits. 11 has even number of digits, and if we take like 4000, 4-digit number, it is also a even digit number. Number of digit is 4, so it is also a even digit number. We will call these numbers symmetric integers. And the second part, the number with odd number of digits are never symmetric. That means this has odd number of digit, it is also odd number of digit, it is also odd number of digit, odd. So these numbers are not symmetric. So we will not check these kind of numbers. Now we look at the second condition that is asking in the question. The sum of first n digits of x is equals to the sum of last n digits of x. So let's understand this problem by taking this example 1, 2, 3, 0. So what is the length of this number? That is number of digits. How many number of digits present in this number? That is 4. That is even. It means it is symmetric. Now we check the second condition that is given in the question. The first half, the left sum, let's call it the left sum. This left sum should be equals to this right sum. If this is equal, we increase the count. So let's check this condition. Left sum, that is 1 plus 2 equals to 3. Now we check the right sum. 3 plus 0, that is 3. This is also satisfied. So both the condition that is given in the question is satisfied. So we increase the count. So we increase the count in this case. Now we will think the approach how we can solve this question. So first we are going to see the brute force approach. In this approach we take the example number 2. First what we have to identify the number of digits, that is odd or even. So what we will do first, we will identify the number of digits present in the number. Identify number of digits. For this we will simply convert this number into a string. And after converting that number, we can simply get these digits by their index. We will convert this number into the string. We will convert these number into a string. Look at this number. The number of digit is 4. That is even. So after identify the number of digits, what we have to do? The second condition, we have to find the sum of first half of the digits. For example, the number is 1, 2, 3, 0. That is the number. We have to calculate the sum of the first half of digits. Let's call it the left sum is equal to the sum of the second half of the digit, let's call it to R sum. We have to check if left sum equals to right sum, then we will increase the count. So this approach we will follow in this example. So let's summarize this approach. In the brute force approach, we check every number. We check every number from low to high. From low to high, for each number, we do the following things. First, we convert the number into a string. Then we calculate the sum of digits of both halves. That is left sum and right sum. If the sum are equal, it is symmetric. And we have to count this number. So we simply increase the number of count by 1. So let's look at the code now. We are going to solve at the Leetcode screen. To check every number from low to high, we will use the for loop here. For int num is equals to low and num less than equals to high, num plus plus. What we have to do the first? First we have to convert this number into the string. So we will convert, let's call it string str is equals to 2 string num. Now the number is converted into the string. So call it L. We can simply calculate the size of this string str. We will get the number of digits str dot length. If the number is even, then we have to check the second condition. We have to calculate the left sum and right sum. And if the left sum equals to right sum, then it is a symmetric number and we have to increase the count. So let's call it L sum. Let's initialize with 0 for int I equals to 0, I is less than L by 2. We have to check the first half of the digit I plus plus. L sum plus equals to str of I. This is currently a character when we convert this number into the string, and when we are trying to access this number by their index, this is the character. So we have to convert this into the digit. So we will simply do this by -0 character. Now this character is converted into the digit. We will do the same thing for the right sum. Let's call it R sum. Initialize with 0 for int I is equals to, now we have to check the second half of the digit L by 2, I is less than L, I plus plus, R sum plus equals to str of I -0 character. Now we have to check the second condition. If the left sum equals to R sum, we have to increase the count. We forgot to initialize the count. Initialize the count here. Int count is equals to 0. In the end of this program, we simply return the count. Now this is working. Let's try to submit this answer. Yes, it is submitted. Now let's understand the time and space complexity. This for loop is taking big of high minus low plus 1 of time, and look at this. We iterate on every digit. This is left part of the digit and this is right part of the digit. We are checking every digit. So multiply this by L, that is length of the digit. So this is the time complexity. And what is the space complexity of this? This approach is taking constant space complexity. Now let's look at an optimized approach. All symmetric numbers, 2-digit numbers, that is between 10 to 99, only those numbers which are multiple of 11 are symmetric. Those numbers are symmetric which is the multiple of 11. What I am trying to say, let's open this number. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and so on. 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. We have to check only through this. Let's observe one thing. Only in this from 10 to 20, only 11 is symmetric. Only 11 is symmetric. From this 21 to 30, only 22 is symmetric. Only 22 is symmetric. That is the multiple of 11. In this from 91 to 99, only 99 is symmetric. That is the multiple of 11. So what we observe here, every two-digit number is symmetric only if it is a multiple of 11. So what we observe here, it is multiple of 11. And look at the constraint of this question. The constraint of the question is maximum number we can get to 10 to the power 4. That is 4-digit number. So we don't need to check the 1-digit number and we don't need to check the 3-digit numbers. We will simply check the 2-digit numbers and 4-digit numbers. So 2-digit number is solved. Now let's find out how we will find the symmetry of 4-digit numbers. Symmetry of 4-digit numbers. In the 4-digit number, let's take the same number that we took in the previous example, 1230. Example 1230. In the 4-digit number, we simply have to check the first 2-digit sum and last 2-digit sum. So how we will find the first 2-digit and the last 2-digit? How we will get the first digit from this number? If we divide this number by 1000, we will simply get the first digit. Let's call it num. If we divide the num by 1000, we simply get the first digit, that is 1. How we will get the second digit? Let's check it out. If we divide this number by 100, if we divide 1230 by 100, we get 12. And if we take the modulus 12 by 10, we will simply get the 2, that is the second digit. So what we will do here, first divide the number by 100 and we will take the modulus of this number by 10. So we will get the second digit. Then how we will get this third digit? Let's find out this also. If we divide this number by 10, we will get this 1, 2, 3. And if we take the modulus of this by 10, we will get the third digit. So we will do the same thing here. We will get the third digit. Now, next, how we will get this fourth digit? Taking the fourth digit is very simple. We just need to take the modulus by 10, num modulo 10. We will get the fourth digit, that is 0 here. And what is our second condition that is given in the question? We have to check the first half, that is, let's call it left sum, and second half, let's call it right sum. If left sum equals to right sum, we have to increase the count by 1. Let's check out the code now on the screen. We have to iterate every number from low to high because we don't know the low is 2-digit number or 3-digit number or 4-digit number or 1-digit number. We will iterate every number here. So int num is equals to low is less than equals to high, num plus plus. First we check the 2-digit number. If num is greater than equals to 10 and num is less than equals to 99. And what is the symmetry of 2-digit number? that number is a multiple of 11. So num mod 11 should be 0. In this we will increase the count. Else if the number is greater than equals to 1000, that is 4-digit number, and num is less than equals to 99, we have to find out the first digit, second digit, third digit and fourth digit. So how we will find the first digit? First digit is equals to, we will simply divide this number by 1000, we will get the first digit. Then how we will get the second digit? We will divide this number by 100 and then we'll take the modulo by 10. We will get the second digit. Then how we will get the third digit? In this we will divide the number by 10 and then we'll take the modulo of this number by 10. We will get the third digit. And how we will get the fourth digit? It is very simple. Comment it out. We will simply take the modulo by 10. Now we have calculated the all 4 digits. Now what is the second condition? The left sum of the digit should be equal to the right sum of the digit. So what is the left sum? Left sum is the combination of first digit and second digit. Let's take it L sum. First digit plus second digit, and what is the right sum? That is third digit plus fourth digit, and we check the second condition of the symmetry. If left sum equals to right sum, then we will simply increase the count by 1. And we forgot one thing in this approach also. We forgot to initialize the count. So let's initialize it with 0. And count is equals to 0. We will simply submit it. So what is the time complexity of this approach? This loop will take the time complexity of big of high minus low plus 1. And these things will take the constant time complexity. So this is the time complexity of this approach. And what is the space complexity of this? The space complexity of this approach is 1, that is constant. The optimized method is way faster, especially when the range is large. We skip converting number to strings and directly work with digits using math. Let's quickly recap. A symmetric integer must have even digits. For 2-digit numbers, they are symmetric if both digits are same. That is, if it is a multiple of 11. For 4-digit numbers, first 2-digit sum should be equal to the last 2-digit sum. That's it for today's problem. I hope now you clearly understand how to solve this symmetric integers problem in both brute force and optimized way. If you found this video helpful, leave a comment below. Like this video, subscribe to this channel for more Leetcode and DSA explanation. I will see you in the next one. Happy coding!